In this video tutorial, we will be introducing the new options for automatic calculation of long-term load combination factors in ADAPT Builder version 21. The program can now calculate long-term load factors automatically for the user using either the ACI multiplier method or the detailed method in compliance with ACI 209R. On screen, we have a FloorWizard model that consists of 3 bays in the X direction and 2 bays in the Y direction. The columns are 18 by 18, and we have no post-tensioning. For other inputs, we just left the defaults of the FloorWizard for this model. Once we have our model, we can go ahead and go to Criteria, Long-Term Settings to open the Long-Term Deflection Settings dialog window. In this window, we can choose the calculation method, either ACI multiplier method or detailed calculations method. Depending on which method you choose, you will have different inputs to modify. At first, we'll go ahead and demonstrate the ACI multiplier method. We'll go ahead and leave the long-term multiplier with the default value of 2, and we'll click OK. Next, we'll come to the Loading Ribbon, Load Combinations button to open the Combinations window. This should be familiar to most ADAPT users. Notice at the bottom left, we have a new Calculate Long-Term Factors button. We will use this button to have the program calculate the long-term factors, but first we need to set up our long-term load combinations. So in this method, we're going to assume all of our sustained loads are applied at the same time, and so we won't stage out our load combination. We'll do an example of staging when we show the ACI detailed method. So I'll go ahead and add a cracked deflection combination, and this will be our sustained load combination for the long-term that will be used for the long-term load combination. Notice we have some new options here to the left of the Analysis Design Options window. That is deflection load type, age at loading in days, and observation day. So this would be the time that we're trying to view deflections at, the day we're trying to view deflections on. So for the deflection load type of our sustained load combination, we're gonna leave it at sustained, but we also have total. So if this was a total load combination, we would want to choose total. For age of loading, we'll go ahead and keep the default of 7 days, and then we'll go ahead and build out our load combinations. We're going to use 0.3 for live load, as 30% of our live load is considered sustained. Note that we have pre-stressing and hyperstatic in this model. I opened the program at PTRC mode, but we're going to ignore PT because we don't have any modeled in this model anyway. So we'll go ahead, and now we have to add a long-term deflection combination. So we'll go ahead and add that. And we also have options that need to be set for the long-term combination. The first is under deflection load type, we have user or auto. If it's set to user, whatever factor for the load case or load combination that the user enters will be directly accounted for and applied when calculating the actions of this combination. If we choose auto, the program will then automatically calculate the factor, so we can put in whatever factor we want, and the program will then automatically calculate that factor, the correct factor, based on the age at loading and the observation day where we're viewing deflections. So if in this example, we'll go ahead and put day 5000 for our observation day. Now we need to include our sustained load combination. So I'll come over and I'll just add a factor of 1 to our sustained load combination. Once this is done and we have the combination set up, we can go ahead and click on the Calculate Long-Term Factors button, and the program will update the factor for the sustained combination based on our age at loading as well as our observation day. The factor is directly interpolated from the ACI deflection graphs. We can go ahead and click OK and now analyze our model. So I'll go ahead and mesh the model, and we'll analyze the model for all load combinations. The next thing we want to do, because we may want to check cracking, is we'll go ahead and generate our design sections. But before we do that, since this is RC slab, I'm going to have the program just create the middle strips quickly for us. Now I'll generate sections and design sections. Once we design the design sections and this is complete, we'll go ahead and calculate the crack deflection. So we'll go back to analysis and calculate crack deflection. And once this is done, we can see both combinations included in this in the loads tab of the results viewer. So we'll click on long-term combination. This is the uncracked long-term combination. And so we'll go ahead and view deflection for this uncracked long-term combination. We turn off our mesh and turn off our support lines. And we can see that we have a total deflection of 0.83 inches downward, max deflection of 0.83 inches downward, and 0.33 inches upward. If we come back to loads and click on cracked long term, we can see the difference in deflection once it's cracked. So based on the reduced stiffness after cracking, we now have 0.89 max deflection and then a max upward deflection of 0.36. So now we want to go ahead and demonstrate the ACI detailed method. And in this case, we're going to go ahead and assume that our loads are applied in different stages. So we'll come back and we'll turn off our results and we'll go back to our criteria long-term settings. In the long-term settings window, we'll go ahead and change the criteria from ACI multiplier method to detailed calculations method. And now we have some more inputs that we have to fill out. This includes the creep factor, the shrinkage factor, the type of curing, moist or steam, and the duration of curing. Note that when we're using this method that the observation day should be greater than day 7 for moist cure and greater than day 3 for steam cure. So we'll go ahead and we're going to keep our default values here and we'll click OK. Next we'll come back to the loading window, load combinations, and now we need to build out new load combinations for our long-term deflection. And so we're going to go ahead and delete these two combinations we created for the other method. And we'll go ahead and start to build out our load combinations. Now in this case, we're assuming that the load is applied in stages. So first we need to set up our stages. So we have 3 different stages. The first stage is when forms will be removed after 20 days. And so we'll go ahead and create our stage 1 combination. It's crack deflection. Again, this is a sustained combination. And we'll set our age of loading at 20 days. And in this case, we're just applying the self-weight because at this point, we've only applied self-weight. So the structure's in place and the formwork has been removed. Now we need to go ahead and add stage 2. So at stage 2 is when partitions and deflection sensitive fixtures are installed. And that will be at day 40 in this project. So we'll go ahead and change the age at loading to day 40. And we'll go ahead and choose to add the self-weight and dead load. Next we have our third stage. And stage 3 is when the final stage and will be when live load is placed on the slab. We will consider this to happen at day 180. So we'll go ahead and put in day 180 here. And this will be, again, self-weight, dead load, and then the sustained portion of live load. So 0.3 for our live load. Next, we might want to add a total load combination so that we can view the total load combination as well. So we'll go ahead and add that. And we'll just add one more total load combination. And we'll change that from sustained to total under the deflection load type. And notice when we do that, the age of loading and observation day are no longer inputs we need to enter. And so we'll go ahead and create our total load combination. And in this case, we'll apply the full live load. So next we need to enter in our long-term load combinations. And we want to enter them in so we can see them at the day we want to observe the deflection. So now that we have our stage combinations and our total load combination, we need to include our long-term deflection combinations. So again, we'll change this to long-term and click Add. And the first long-term deflection combination will be the long-term deflection at day 40. So we'll say long-term 40. We'll go ahead and change this to auto because we want the program to automatically calculate the correct factors based on the observation day. And the observation day is day 40. So in this day, we're going to take into account stage 1 and stage 2. Next, we'll go ahead and add, and again, we're just adding an arbitrary number for the load factor. Next, we'll go ahead and add long term, where we're viewing deflection at day 180. So again, this is an auto calculated factor. We want it to automatically calculate the factors, and we want observation day at 180. And at this point, we'll have both or all 3 stages. So we can see the program's already started to recalculate the factors based on the age at loading and the observation day. So next we want to add 2 total long-term deflection combinations. So we'll say total deflection, and this will be at day 360. And again, we want to automatically calculate the factors. The day here is 360. And in this case, we'll include stage 1, stage 2, stage 3, and total load. We'll do one more because we want to view the total deflection at day 5000 now. So we'll go ahead and create that auto combination, or again, auto calculate the factors. We'll do the day is 5000, and again, we'll include the same stages and the total load combination for this combination as well. Lastly, we may want to know the incremental deflection, so we'll add one more long-term deflection combinations. And this one we'll go ahead and create incremental deflection, and this is between day 40 and day 5000. So for this combination, we're just going to use our user applied factors. We're not going to recalculate factors based on, we're not going to recalculate the long-term factors. So we put it on user, and in this case, we're going to take long-term deflection of 40, actually total deflection at day 5000, and we're going to minus the long-term deflection at day 40 to get the incremental deflection. At this point, we have our load combination set up, and we can click calculate long-term factors if they have not already automatically calculated. And we can come over and we can see the program adjust the factors for each stage. And we can go ahead and exit this window now and analyze the structure. So now we're analyzing with all these combinations. And once again, once the analysis is finished, we'll go ahead and design the design sections. And once the design is done, we'll go ahead and calculate crack deflection. Go back to analysis and calculate crack deflection. And now we can come, once this is finished, we can come to the loads window, and now we can see the different stages and we can view total deflection at day 360 or total deflection at 5000. We can view incremental deflection and the long-term deflections at day 40 and 180. So we'll go ahead and view total deflection, uncracked total deflection at day 5000. We can see in this case we have a total deflection of 1 inch and then an upward deflection of 0.4 inches, max upward deflection of 0.4 inches. If we come back to the analysis or the loads tab, we can go and click on the cracked total deflection 5,000 to see the deflection once the slab has cracked and stiffness has been reduced. So we click on the crack deflection combination, and now we can see we have a total of 1.1 inches downward deflection, max downward deflection, and a maximum upward deflection of 0.545 inches. The new methods implemented for the calculation of long-term load combination factors is meant to provide a more accurate result for the user. For more information on the calculation of long-term load factors and its implementation within Adapt Builder, please refer to the Adapt Builder Help menu. The Help menu could be reached by the Help button. And in the Help menu under Loading, Load Combinations, we have the Calculate Long-Term Factors topic. For more information, please visit the REZA website at www.reza.com or email us at adaptsupport@reza.com.